Good day, viewers. Welcome to another exciting class with Mr. Simplicity. Please, if you haven't subscribed to this channel, please do that right now. Subscribe to our channel and turn on the notification bell so that you will always get notification from us each time we drop a video. Okay, today I will be taking us on the topic rules of differentiation. In this series, we are going to be looking at about 5 rules of differentiation and how we can apply them individually. The subsequent video will look at complex problems where they can be applied. Thank you for joining us today. Let's go straight to the class. So we are going to be starting with the general rule. General rule is usually known as the polynomial rule. Okay? Because this rule applies majorly to polynomials. General rule says that if y is equal to x raised to power n, which is a polynomial, then the differentiation, which is dy dx of y, will give us nx raised to power n minus 1. What this simply means is that anytime I'm differentiating a polynomial, for instance, if I'm giving y equals to x raised to power 3, the differentiation, which is dy over dx, will be equal to multiply with the original power, 3x, and subtract 1 from the original power, 3 minus 1. You get it? So this is what the polynomial rule means. Anytime you have an index number, to differentiate it, you multiply by the original power, 3 times x will give us 3x, then subtract 1 from the original power, 3 minus 1, which eventually will give us 3x squared. Let's take a look at another one. Also, if I'm giving, for instance, y equals to 3x raised to power minus 7, for instance, the rule remains the same. Multiply by the original power, which means dy over the x becomes minus 7 times 3x will give us minus 21x. Then subtract 1 from the power, I'm going to have minus 7 minus 1. Did you get the concept? This will eventually become minus 21x raised to power minus 8. So this is what the polynomial rule says. It says whenever you are given a polynomial, multiply by the original power and reduce the power by 1. So every time you differentiate a polynomial, the power reduces by 1. Okay, I hope that's taken. So let's look at some more practical examples for this. So this is a more practical example. We are given a polynomial that says y is equal to 2x cubed minus 7x squared plus 5x minus x. What you need to quickly understand in this question is that x cubed has a power which we can use to multiply, x squared has a power, yes, we can use to multiply, but x has an invisible power which we know is 1, right? But a constant usually have the polynomial x raised to power 0. Because x raised to power 0 is 1, that's why they usually don't put the x there. Are we together? So which means we can see anytime we have a constant as multiplying x raised to power 0. Okay? Alternatively, you can just know that anytime you meet a constant, which is going to be part of our differential table, anytime you differentiate a constant in differentiation, your answer is 0. Okay? So that we don't do more than necessary, we are going to remove this part and establish that anytime I differentiate an ordinary number with respect to x, my answer will be 0. Is that okay by us? So now let's differentiate this function with that understanding. So differentiating this, dy over dx is going to be 3 times 2x will give us 6x, 3 minus 1 will give us 2. 2 times minus 7 will give us minus 14. 2 minus 1 will give us 1. 1 times 5 will give us plus 5x. 1 minus 1 will give us 0. Then the constant is 0 like we already said. So with this now, we know our answer is 6x squared minus 14x plus anything raised to power 0 we have said is 1. Therefore, 5 times 1 is 5. We can also establish this. Anytime you differentiate a polynomial in which the variable has power 1, then the answer is the constant. So it means that if I differentiate ax, I'm going to get a. That's what it simply means. Okay? Anytime I differentiate ax, it will give me a. Anytime I differentiate 157x, it give me 157. Okay? So anytime the power of the polynomial is 1, when you differentiate it, it gives you the constant. It gives you the constant. So that's what has happened here now. 5x, since x is power 1, usually not written, that means if I differentiate it, I get 5. So that's what, with that, I'll be able to escape this extra step. All together? So that is it. So let's take another example. In this second example, we'll notice that some of the variables are at the denominator where they are found. Like we have 3 over x, we have 4 over x cubed. Okay? In situation like this, I usually advise that you move the variable from the denominator to the numerator before you differentiate, which means we are going to do a bit of simplifying before we carry out the differentiation. So if I'm going to do that, it means I will have to rewrite y, which is 2x raised to power 7 plus 5x raised to power 2 minus 3x raised to power minus 1. The law of indices say when you move a variable from the denominator, it takes a negative power. Okay, whatever power is carrying becomes negated. Similarly, here we are going to have 4x raised to power minus 3. Okay, so with that in mind, we can go ahead now and apply our general rule of differentiation. So if we do that, we have dy over dx to be equal to 7 times 2 will give us 14x minus 1 from the power you have 6 plus 2 times 5 will give us 10x minus 1 from 2 you have 1, right? Then here we have, sorry, this is minus 1. Like we said, the power become negated. So here we have minus 1 times minus 3, that's plus 3x. Then minus 1 from the power, minus 1 becomes minus 2. Minus 3 times 4 becomes minus 12, right? So that minus 3 minus 1 becomes minus 4. So I'm done differentiating. So you observe that if I had not moved the denominator upwards to show this, it becomes more complicated to differentiate, except you're already an experienced calculus student. Okay? So to make it easy, we always move it whenever the variable is at the denominator and differentiation become as usual. Are we together? And take note when you are dealing with minus minus. Okay? Minus minus, so that you don't make mistakes. Some people will say minus 1, 0. It's not because they don't know it, but because they are not conscious. That's why I'm drawing your attention to that. So let's go to the next. Before we go to the next question, we can simplify this by removing the negative power. I will do that by taking them back to the denominator where they belong. So it means dy dx finally becomes 14x raised to power 6, 10x raised to power 1, plus 3x raised to power, 10x raised to power 1, plus 3 over x squared minus 12 over x raised to power 4. So these are answer for this question. Okay, the next question we'll be taking talks about roots. Roots. Okay, so when you are faced with this kind of question, you are going to eliminate the roots first before you ever start to differentiate. And to eliminate the root, we have to apply our laws of indices. One of the laws of indices says the nth root of an index number is equals to the index number with the root dividing the power. Okay, so if I have, for instance, square root of x, this will be equals to x raised to power, the power of x here is 1 over the root here is 2 square root. So the power over the root, that's how you eliminate the root. The power over the root, m over n. Okay, so if we do that, if we apply that to this question, if we apply that here, our y will become x squared over 3 plus 1 over x cubed over 2. So in this case, we have eliminated the roots. Okay? Then the second thing we want to take note here is what I mentioned earlier. When the variable is at the denominator, let's move it to the numerator. If you do that, it makes the differentiation more direct. Okay? So let's do that quickly. Y becomes x raised to power 2 over 3 plus x raised to power minus 3 over 2. So now we can differentiate. So if I should differentiate what I have on the board now, the y over the x will become 2 over 3 times x, 2 over 3x. 2 over 3 minus 1 will give us minus 1 over 3. The minus we have set the positive sign here. So minus 3 over 2 times x will give us minus 3 over 2x. Then minus 3 over 2 minus 1. So when you minus 1 from this, will give us minus
5
minus
over
1 over
2.
2. So this is what we have at this point. So what we need to do now is to take the variable back to the denominator to make it positive. So this will become 2 over 3x raised to power 1 over 3 minus 3 over 2x raised
X
to power
raised to
1 over
power
2.
5 over 2.
If you simplify this further, we can reverse the root. X raised to power 1 over 3 can become 2 over 3 cube roots of x minus 3 over 2 square root
Of
of
x
x.
raised to power
So this
5.
will be our answer for the differentiation. Okay, take note. This is 1 over 3. The denominator is always the root. So if you are reversing it, it's cube root of x raised to power 1, and 1 can be invisible. The same thing here, if you are reversing this half here, this is square root. The denominator is your root. So this becomes square root of x raised to power 1, and
Power
1 is
5.
invisible. So that is it for the first rule of differentiation. Okay, so I think those 3 examples explains it clearly if you take your time to go through the process. So we're going to look at another rule.